Hi Math 3 students. Today we're going to go ahead and go over the difference between an even and an odd function. Now, it's incredibly important that you understand that this is not referring to an even and odd degree. If it's an even degree, it can be an even function, and if it's an odd degree, it can be an odd function, but it does not necessarily mean that if it's an even degree, it automatically is an even function, okay? So keep that in mind when I'm asking about even and odd function. That's different than even and odd degree. All right, so when you have an even function, you're going to have a graph that is symmetric about the y-axis, meaning that the y-axis here acts like a mirror, and essentially whenever you plug in a value, you're going to get out, like here, let's say we plug in a 3, okay? When you plug in a -3, you're going to get the same thing out, okay? So that means, like, if you plug in a 10 and you get out 8, when you plug in -10, you're going to get out when you plug in -10, you're going to get out 8 as well, okay? So basically it just means when you plug in one thing, you get the, and you plug the negative in, you're going to get the same thing out. Then we have odd functions. Now, odd functions are a little bit trickier. They are symmetric with respect to the origin, which is 0, 0. So what that means is that if you rotate this, it will rotate about the origin just like that and be symmetric about it, okay? And let's say if we put in a +3 and we get out a value, when we put in a -3, we're going to get out the opposite value, okay? So basically, with even, when you plug in a negative value, you're going to get the exact same thing. With an odd function, if you plug in a negative value, you're going to get the opposite, okay? So when we are looking at functions and trying to determine if they are an even or odd function, first you check to see, okay, is it an even function, right? Is it symmetric about the y-axis? And here in this case, this is not symmetric about the y-axis, so it's definitely not an even function. Now, it looks like it could be an odd function possibly. However, keep in mind, one really important thing about odd functions is that they have to go through the origin. Even functions do not have to go through the origin, but odd functions do. This does not go through the origin. And if we were to try and check to see if this was symmetric about the origin, when I rotate it, you can see it doesn't land in the exact same spot. So this is not symmetric about the origin. So it's not odd, it's not even, so we would put it's neither. All right, here for number 2. This one is an even function. We can see that if we were to like fold this coordinate plane if we were to fold the coordinate plane on the y-axis, the graph would overlap, right? It's like a mirror. This is an even function. Here for number 3, again, we can see that this goes straight through the y-axis here. If we were to fold it, it would, we could see that it's definitely a mirror of itself. This is an even function as well. Here for number 4. So this one does look like it's going to be an odd function. We can see that it does go through 0, 0, which is a good sign. And I'll go ahead and show you that we do, in fact, have that symmetry. Oops. About the origin there, right? If we rotate the graph, we end up with the same thing. It's going to be an odd function. Here, this one, again, notice it goes through the origin. We'll check to see if it has that symmetry. Whoa. And it does, in fact, have that symmetry. All right, so this guy is going to be an odd function. This one, it's not symmetric about the y-axis, and it doesn't go through the origin, so we know right away it's not an odd function. So this is also neither. All right, so let's see. Let's take a look here at these problems. I like these because it allows you to identify like if the degree is even or odd, but then you have to identify if the function itself is even or odd. So like here, we can see that this guy would be an odd degree, okay? We know it's an odd degree because the end behavior goes in opposite directions. This is a polynomial, just like we've been doing this unit. However, it's not an odd function, and the reason for that is, first off, it does not go through the origin. And second, it's not symmetrical about the origin either, right? Like, we can see, okay, this one goes through like 5.5, but this one goes through 3.5. That's not symmetric about the origin there. So what we would say for this one is that it is an odd degree, but it's not an odd function. All right, here for this one. This guy, we can see by the end behavior, the polynomial goes, both go in the positive direction there. So this is going to be an even degree. So then to see if it is an even function, we check to see, okay, is it symmetric about the y-axis? Which in this case, it is not. So we would say it's an even degree, but not an even function. Here for number 11, we can see by our end behavior, they both go in the same direction. So we would say it's an even degree. Do we have symmetry about the y-axis? In this case, we actually do. So it's an even degree and an even function. Here, by our end behavior, we can see that it's going to be an odd degree. So now to check to see if it's an odd function, do we have that symmetry about the origin here, right? Well, we can see, okay, you know, it looks like we have points in similar kind of locations here, right? And then we can kind of check to see, okay, do we, oh, I didn't trace it nicely enough. I can go ahead and do my little rotating trick here to check it. And yep, that looks pretty darn good. So this one is going to be an odd degree and an odd function. All right, so these last ones here goes back to the idea that, like, if we have an even function, when we have an input, and then that input negated, it's going to give us the same output. When we have an odd function, if we have an input and that input negated, we get the output negated. We get the output flip-flop, basically. So in this case, let's see, number 18, it says we have an even function. All right, so we know that it's going to follow this pattern here, right? And it tells us they want us to find f of 1, okay? Well, in an even function, f of 1 is going to equal f of negative 1, right? You can see that these guys are equal here. So f of negative 1 is just going to be negative 8, okay? Based on this table here. So, well, what is f of 1 going to be? If our input is 1, what's our output? It's also going to be negative 8, right? It follows this pattern of the outputs matching when the inputs are negated, when they're flipped. All right. Let's see. Let's try an odd one. So here, right, they want us to find f of negative 1. And here we are able to see that f of 1 is 4, okay? Well, with odd functions, when you negate the x values, you also negate the y values. So this is going to be negative 4. Our output for f of negative 1 would be negative 4. Here for number 20, they tell us that it's even. So that means that 12 and negative 12 are going to have the exact same output, right? So if positive 12 has 8, negative 12 is going to have 8. So that would be my answer. All right, so then for number 22, they tell us that it's odd. They want us to figure out what the output is for negative 4. Well, the output for positive 4 is 12. So that means that the output for negative 4 is going to be negative 12.